This is Mr. Ashton going through the Mathematics Numeracy Unit 1 Non-Calculator Intermediate paper from the summer of 2017. Okay then, so the first page gives me a load of information, so properly kicked off into a numeracy style paper that it's got lots of words going on, so make sure you've read the question before I start going through it. So it says, for the last 7 days I've recorded the number of cars parked in my local car park. At 10 a.m. each day, this is what I found. The car park always had some cars parked in it. The greatest number was 11, the range was 8, the median was 9, the mode was 10. On one day there were 6 cars in the car park, on another there were 7. Gareth asked what was the mean number of cars in the car park for these 7 days. Complete Sean's reply to the Gareth's question. You must list the 7 numbers Sean recorded, show while you're working. The mean number of cars in the car park at 10 a.m. for these 7 days was this amount. Okay, now I'm going to go from this, okay? So 1, 2, 3, 4, 5, 6, 7 days. I'm going to rank this from the highest number to the lowest, okay? Now, my tip to you is to go through the bullet points. They will be in an order to help you answer this, okay? So the greatest number was 11. So we can put 11 there as the highest number. The range was 8. So 11 take away something gives me 8. Well, we know what that must be. That must be 3. Okay, so 11 take away 8 will tell me the lowest, which is 3. It then says the median was 9. So the middle of that, which should be 4, 3 either side, is 9. The mode was 10, so we've got to have at least 2 10s. So there's only 2 10s that feed into there, so 10 and 10. On one day there were 6 cars parked in the car park, on the other there were 7. Okay, well that's told us what these numbers are here. Okay, so as I said, bullet points will be in an order to help you answer that. To then go and work out what the mean is, I need to add them all together. So let's do 3, add 6, add 7, add 9, add 10, add 11. Is that it? 1, 2, 3, 4, 5, 6. So I missed one. 3, add 6. Oh, there's 2 10s, isn't it? Add another 10, and then divide that by 7 to work out what the mean is. Okay? Now, I'll say that's the mean. If we add all those together in our head, it's going to be quite hard without trying to spot for tricks, okay? So let's add them up in logical orders here. We've got a 3 and a 7, that's 10. We've got a 9 and 11, that's 20. So we are on to 10 and 20 so far is 30, 40, 50, and 6. So 56 divided by 7. 56 divided by 7 is 8, so the mean number was 8. Okay, so I can fill that in there, but as long as you've got your answer in there, that should be fine as well. Okay then, the next page says, Larry and Yvonne are sisters. They both live in Cwm Echel. They do not go to the same school. The graph represents each of their journeys to school and back. So the dotted one is Larry's journey, the solid one is Yvonne's journey. It says, at what time does Yvonne arrive home from school? Circle your answer. So Yvonne is this one here. So distance from home, so she goes away from home, she stays the same distance away, and then she arrives home here. Okay, so this is all about reading a graph scale. If that's 2 and that's 4, this must be 3 or 1500 in 24-hour clock, and then that is bang in the middle between 1500 and 1600, so it's 1530. The next question says, so I'm going to leave the graph here so I can go back to it. Larry cycles along a straight road to school and back. How far does she cycle when she's going to school and back in one day? So this is the other one. Larry, so she's this one. How far does she cycle? Well, she cycles 8 to school, stays at school, and then she comes 8 back. So that is a total of 16. So they probably put 8 and 16 there. It's 16. It then says, Martha looks at the graph and says, the school that Larry attends is 2 kilometres further from Yvonne's school. Now, she's made that conclusion by saying 6 and 8, they're 2 kilometres away. However, we just know that it's their distance from home, so Larry could be setting out this way, and Yvonne could be setting out this way, so they could be going in completely different directions. So is this true? It's certainly true. It's certainly not true. It's not certainly false. They could be going in exactly the same direction. I'm going to say we can't tell. And we can't tell because they may, I'll put that in different directions. Okay, over the page then, new question. Again, true numeracy question here, lots of writing. We're told we're going to be assessing the quality of our organisation, communication, accuracy. That's only 2 marks. Now, this is 8 marks. I'm guessing we've got all of the other page to write on as well. We do. 8 marks for maths. So let's make sure we get that sorted before we worry about that. The tips I can give you for getting those marks, make sure you put pounds in, metres squared, or anything that you're doing in terms of work out area or cost, and then just little lines give it, or little arrows just pointing to anything that you work out, and explaining why you've done it. Okay, so it says tents covering the ground are less. Tents covering the ground area are less than 12 metres squared cost £14 per night. Greater than 12 metres squared cost £16 per night. We're then told, and as well as that, we charge you £4 per person. Stay 5 nights, get the next night completely free. This means no charge for tents or people on every 6th night. Rodri and Lars are planning a camping holiday staying here. They're only taking 1 tent between them. Take a tent covering a rectangular area measuring 2.5 metres by 4.4 metres. They both stay for a total of 12 nights. Their holiday is just 8 weeks away. They each plan to save £15 per week from now until their holiday time in 8 weeks' time. How will the amount they save be enough to pay for their holiday? Okay, so again, let's go through this. You do it bullet point by bullet point, okay? They take 1 tent between them. Okay, so only 1 tent. The tent covers an area of measuring 2.5 metres by 4.4 metres. There's our first bit of maths we can do to get a mark, okay? So 2.5 times by 4.4, and I'll say here, this is to work out area of tent. Okay, so it does not need to be an essay here. Let's just tell them what you're doing and why. Now, this is a maths, new. I would normally say something like 4.4 times 2, which I know is 8.8, and then do 4.4 times 3, which I'm not so confident with. I know that 4 times by 3 would be 12, and 0.4 times by 3 would be 1.2. Okay, so that's going to be 13.2. So I know that 4.4 times 2.5 would have to be in the middle of these two here, but I'm not really spotting an obvious way of spotting that. Although I could say it's going to be half of the 4.4, I suppose. Half the 4.4 would be 2.2. So if I add on 2.2 onto that, I would get 9 add 2 would be 11.0. Yes, 11.0, that seems correct to me. But what Napier's bones, as you might call it, and to do that, you do something like this. This method will work quite nicely with decimals. So we had 4.4 here, 2.5 here. Follow the decimals. There and there. Where do they meet? Here and here. So the decimal is along that line. There. And then work it out. Say 4 times by 2 is 8. So 0, 10s, 8 units. 4 times by 5 is 20. 4 times by 2 is 8. And then 4 times by 5 is 20. If you add those up in the diagonals, we get 0, 10, carry 1. 8 and 2 is 10. Add 1 is 11, carry 1. And then 1, 11.0 metres squared. Okay, so their tent area is 11 metres squared. That's the first bit done. Okay then, now from here, I've worked out, right, let's go through the bullet points so far. I've worked out what this area is. I can now do some work with this. So if it's less than 12 metres squared, which theirs is, their area is 11 metres squared. So the cost is £14 per night, but we need to be aware of this bit here. So it's not quite as simple as saying, right, they're staying for 12 nights. They're staying for 12 nights, but they get every 6th night free. And there's, okay, so for every six days, you pay for 5. I'm going to write that down here, okay? For days, you pay for 5 days due to the offer. So for 12 days, pay for 10. Okay, so for 12 days you pay for 10. So I'm now going to do 10 times by £14 per night. So 10 times by £14 will give me 140 quid. So that is the tent cost. And then we're told that we get charged £4 per night per person. Now there's two of them. It's Rodri and Lars, okay? So because there's two of them, I want to do 2 times by £4 per night, and I'm going to pay that for 10 days, okay? So let me just point to each thing. So 2 people paying for 10 days. Okay, so 2 times by 4, that's 8, and then £8 times by 10 would be 80 quid. Okay, so their total cost is equal to £140 plus £80. So as I said, don't just have calculations popping up out of nowhere, just show where you're going to get the next answer from, which is £220. Okay, now going on to the next bit of this question now, it says their holiday is just 8 weeks away. 8 weeks away, they plan to each save £15 per week for their holiday in 8 weeks' time. Okay, so they each pay £15 times by 2, which equals £30 saved each week by both. Okay, then they're going to save that up for 8 weeks, so it's £30 times by 8 to get £240 saved in total. So are they going to be able to do it? Have we actually answered the question? It says, will they be able to save enough money to pay for their holiday? So yes, they will, because their holiday is going to cost £220. They save £240. So yes, they save enough money. £20 spare. Okay? It didn't ask me that bit. That's why I put that bit in brackets. Okay then, question 4. Have a quick read of the question. I'll answer it in about 10-15 seconds. Okay, it says Lazar wants to send a package to Germany. He looks at the pricing charts for 3 different companies: Parcel Max, Direct Go, Pack to Save. Lazar's parcel is a cuboid measuring 10 by 20 by 30. Now, if we look here, it says the sum of all 3 dimensions in centimetres. Sum just means to add them all up, and then we times it by 60p. The volume measured in centimetres cubed. The total area of the 6 faces measured in centimetres cubed. So we need to go and work out the volume and the surface area of that, okay? So let's just do the Parcel Max first, because it's in order, and it's the easiest one to start off with. The sum of all 3, so 20 add 30 add 10. So 20 add 10 add 30 in any order would be equal to 60 centimetres. That's the sum of all the 3 dimensions. I now times that by 60p, 0.60. 60 centimetres times by 60p would effectively be 3,600 pence. So in pounds, that would be £36. Okay. Direct and Go, I need to work out the volume. To work out the volume, I'm going to do 30 times 20 times by 10, times all sides together to get 3 times 2 times 1, which would be 6, and then 1, 2, 3. So 3 zeros, so 6,000 centimetres cubed. I then do that multiplied by 1 pence. So it's 6,000 pence, which would be 60 quid. So that was much more expensive. I wouldn't go with them. And then the other one, I need to work out the surface area. So to do that, we call the front rectangle A, the top rectangle B, side rectangle C. So to work out the front area, I'm going to do 20 times 30, which is 60. But because it's at the front, it's also going to be at the back. So I'm going to double it to get 120 centimetres squared. To work out the top rectangle, I'm going to do 30 times 10, which is going to be 30. Oh, hang on. That's 600. Okay, so that's 1,200 centimetres squared. This is going to be 300 times by 2, which would be 600 centimetres squared. And then I'm going to work out the side rectangle, which is 10 by 20. 10 times by 20 would be 200 centimetres squared. Double it because it's on both sides. Be 400 centimetres squared. Add all those together to work out the total surface area. That's 1,000. 1,200 will give us a total of 2,200 centimetres squared. Now we find all 6 faces and we times that by 2p. So 2,200 centimetres squared times by 2 pence would be 44,000 pence, which in pounds would be 44 pounds. Okay. Now, in terms of that, then we're looking for the cheapest. So the cheapest was the very first one that we did. Does it ask me that? Assuming. It says, what is the percentage saving that Lazar will make choosing the cheapest option opposed to the most expensive option? Okay, so the formula we're after using here is the difference divided by the original times by 100. Okay, so we need to find the difference between the cheapest one, 36, the most expensive one, which is 60, the other one's 44. So that would be the difference of 60 and 36. So 60 take away 36, divided by the original, the most expensive option. So divided by 60 and then times by 100. 60 take away 36 would be 24. 24 out of 60 times by 100. Now, problem is, I don't know how to do that without a calculator, but what I can do is cancel or simplify this fraction. I know that that is divisible certainly by, let's just go in the easiest options here. Let's halve top and bottom. So 12 out of 30 times by 100 is the same as 6 out of 15 times by 100. Hang on, I feel like I've made a mistake here. No, from checking the working, it's fine so far. And then 6 out of 15, both divisible by 3, so that would be 2 out of 5 times by 100. Now that, as a fraction, we should know what 2/5 is. 1/5 is 20%, so 2/5 would be 40%. Okay, so that would be 40% there. Okay, then over the page to page 10 and question 5, it says, Jasmine has entered herself, Sophie and Bryn into a talent contest. Bryn only had a minor part. Bryn and Sophie and Jasmine, who won the contest, they share the prize money in the ratio of 2 to 6 to 7. With Bryn getting a smaller share, Jasmine won 560. Now, this bit's really important. The order they're given in here will be the same as that order there, okay? So I'm going to write it out as follows. I'm going to say Bryn, Sophie, Jasmine. Underneath, I'm going to write 2 to 6 to 7. We're then told that Jasmine won 560. So Jasmine won 560. So her share is 560. So I'm going to write out the ratio dots again and write 560 there. What have I times 7 by to make 560? Well, ignore the 0. What have I times 7 by to make 56? 8. So I've times it by not 8 but 80. So I need to times each of these by 80. So 2 times by 80 is easy. That's 160. It's your 6 times 80. That's probably going to be a bit trickier. But 6 times 8 is 48. So 480. So Bryn's share, the minor part, he's 160. Sophie has received 480. Okay. It then says, Jasmine gave 15% of her winnings to charity. How much did she have left? So let's work out 10% of what she had. So she had 560. So 10% is 56. 5% would be half of that, would be 28. Add those together, we get 15%. 15, 7, 8. So 15% is equal to 84 quid. So 84%, or £84 given away. So in terms of how much she has left, she is going to have 560 take away 84. So if we borrow one from there, in readiness, we can get 6, 7, 4. She has £476 remaining. Okay. Question 5b, page 11. It says the talent contest is held once a year. Every year, the cost of putting on the talent contest increases 10% to the previous year. In the summer of 2014, the cost was $6,600. Calculate the cost of working out of the summer contest in 2017. You must show all your working. So let's do it year by year. So in 2014, we know it cost 6,600. In 2015, it's going to cost 10% more. So 10% of 6,600 is equal to £660. So then we want to do 6,600, the cost in 2014, add the extra money. So that's going to be 0, 6, 12, 7. So in 2015, it's equal to £7,260. In 2016, it is going to be 10% more than this. So 10% of £7,260 is equal to 726. We're now going to add that on to 7,260 to get 7,986. So then in 2017, which is the final year they've asked me to work out for, I need to find 10% of the new amount. So 10% of 7,986 would be £79.86, and I need to add that on to the previous cost. So 7,986 add 7. Oh, it's going to be more than that actually. It's going to be 790. 7, 8. Oh, let's just start that one again. 7,986. This will be 798.60. Okay, so 0, 6, 14, 17, 18, 17, 8. So I make it as £8,784.60. Okay, over the page we're given a couple of graphs, and then we've got some questions here to go and work out. So we're told that they're group. What are they? They're frequency polygons. So frequency polygons to show 16-year-olds doing what they're doing using social media. Okay, it says how many of the 16-year-olds took part in the survey. So 16-year-olds are here. So how many took part? Well, 0 there, 40 there, 60 there, 40 there again, 70 there, and then 20 there, and then 0 there. So we need to work out all of those added together. So we've got 40 plus 60 plus 40 again, plus 70 plus 20. Okay, so 40 plus 60 is 100, 40 plus 70 is 110, so that's 210, and then add the 20 is 230. We're then asked how many more 16-year-olds than 18-year-olds spent between 15 and 25 minutes. So between 15 and 25 minutes, here's 15, here's 25, we're after this bit here. So if we look between 15 and 25, we're after this bit here. So there were 60 students who spent between 15 and 25 minutes, who were 16, and of the 18-year-olds, there were 20. So it's going to be 60 take away 20, which is 40. So 60 take away 20 is equal to 40. That's my answer there. Part C. Wesley says the 16-year-olds generally spent about the same time using social media as the 18-year-olds. Use the frequency polygons. Using the frequency polygons, how would you explain Wesley's statement is not true? Okay, so Wesley is looking at the peak performance both being 40. But if you look at the frequency polygon here, it dramatically decreases with the 16-year-olds when it comes to 50, and there's none there at 60. Now, if you look at the peak performance there and the peak performance there, that is the same as the 30 there. So it's about the same number. 60 students here use it for 30 minutes, and 60 students here use it for 50 compared to 20, okay? So I'm going to say, although the frequency polygons peak at the same number, a large number of 18-year-olds use for 60 mins students compared to 16-year-olds, which was 20. Okay. Okay, then over the page. Okay, we have got the following diagram there. We're told that two lines are parallel. Carl is making a jigsaw puzzle. Carrie is making a jigsaw puzzle. She has designed a pattern on one piece of paper. Carrie plans to make each piece of jigsaw a different colour. Part of the plan is shown below. Now, this has been making sure that you understand parallel lines. So it says the diagram's not drawn to scale. It then says, can you find the 4 missing angle pieces here? So I'm going to use my tracing paper here to mark out 86 degrees here. Now I know along these two parallel lines here, this is what we call a transversal line. That 86 will slide down and be in exactly the same place as D. So that's 86, and I can use angles on a straight line to work out C. That must be 94, because 94 add 86 to make 180, and that's angles on a straight line. So I've actually done the last two letters. Using this transversal line here, I know that that's 72 angle here can slide along there, so it'd be that angle there, opposite B, not opposite, sorry, on a line with B, so I can work out B is 108, and then the 72 is opposite A, so I know that is also 72. Okay, so over onto the other page. A I had as 72 degrees, B I had as 108, C I had as 94 degrees, and then D I had as 86 degrees. Okay, now each of those are correct. Now I need to go and actually draw it. Okay, so where I've got 8 centimeters, I need to measure an angle of 72 degrees. Now I only have a 180 degrees protractor. You may have a 181, but it shouldn't be drastically different to what you do here. Top tip, at the end of each line, I'm going to draw a blob to help me find the centre of my protractor on that line. So I'm going to put the centre there. I'm going to make sure 0 is perfectly on that line. So can you see now there's no overlap at all, 0 is on that line, and the centre is on what we call the crosshair. Now, I'm looking for 72. A was 72 degrees there. So I'm coming around here, and so I can measure 70, and then I'm going to be absolutely perfect there to get 72. Okay, now what I'm going to do in the first instance is I'm just going to draw a faint line going through there, okay? I know that that line has to really be 6 centimeters. So now I have the line, I'm going to line up 6 on that dot there, and I'm looking for where it's 0, which would be there, okay? So I'm going to make this bit will be, that's where that is, okay? Now, I know that's parallel, and I know this angle is 108 degrees. I'm going to go and write in here 72 degrees. So what I'm going to do now is get 0 on that new line that I just drew, and the crosshair there. You can see 0 is on that line perfectly. And I'm going around until I see 108. There's 100. There, there's 105. So 108 would be 3 little dashes on there. Okay. So what I'm going to do now is draw a line. Again, I'll just do it faintly. There. Okay. Now I know that angle is 108 because I just measured it accurately. And then I am looking to draw an angle of 94 or 86. So I'm going to probably just come down to the bottom here and do the 86. Move my protractor around to get the 0 on that line there, crosshair there. Now, I can see here that on the outside that my numbers are too big, so I'm actually using the inside measure scale. So I'm looking for 86, there's 80, there's 90. So it's somewhere in between these two. I'm going to come out to 80 to 280 and going this way. So 86, there's 85, 86 would be 1 back. Okay, so then I would line that up with a dot there, going through there, and I'm going to draw that now nice and firmly now, because I know it would stop at that line anyway. And if I wanted to check, I'd check that angle is 94 degrees. It will be, but I could go and double check it if I wanted to. Okay, now I'm just going to make sure that all the lines are nice and bold that I've drawn in. Okay, now if I had a rubber, I'd probably rub those out, but what I will do just to show the examiner they're not wanted, I'm just going to faintly just scribble out there. Okay, now in the real exam when you're doing this, it wouldn't be a bad idea, once you've done it in pencil, just to go over in pen as well, just so it's really nice and bold for the scanning in, so your papers get scanned in. and sensor markers can mark them remotely. Okay then, over the page, I've got a new question. Just sort everything out here so everything's nice and organised my end. Okay then, question number 8. It says, Bethan builds a rectangular sheet pen. The perimeter fence of every sheet pen is 18 metres long. It costs her £1.10 for every 0.5 metres of fencing made to used to make the sheet pen. Calculate the cost of the fencing used to make this pen. Okay, so in terms of this pen here, we know that the perimeter fence of the sheet pen is 18 metres long. Okay, so I'm going to draw just a generic rectangle, so I know it's a rectangle, and I know that the perimeter would be the full distance round, and I know that the perimeter is equal to 18 metres. So that means I want to know how many 0.5s fit into that. Oh, no, I'm going to write it like this. 0.5 metres of fencing is equal to £1.10, and I want to know what 18 is. So 1 metre would be twice as much, would be £2.20. And then I want to know 18 metres. Now I'm going to do this in a clever way. At least I think it's clever. You may disagree. I'm going to find 9 metres worth, and then I'm going to double that, okay? Because I know what 1 times by 9 is, and I can do 220 times by 9 a little bit easier than doing 220 times 18. So 220 times 9, I'm just going to come right over here. Nothing times 9, nothing. 2 times 9, 18. And then 2 times 9, 18, add the 1 is 19. So I know that 9 metres of fencing would be £19.80. So 18 metres of fencing would be twice as much as that. Now that is 20p short of £20. So double of it would be £40, but then 40p short. So this would be £39.60. Okay. We're then told here that, oh, 1 second. Okay, then. So it says, find the length of Bethan's sheet pen, or the length of Bethan's sheet pen is 2 times the width. Find the length and the width of the sheet pen you must show while you're working. Now, if I draw out that rectangle again, it's really, really important the way that we take this from here, okay? It says the length is 2 times the width. Okay, now at the moment I don't know either, so we tend to say that's the length, that's the width. But what I do know, I know the length is twice as much as that. So I'm going to say L, the length, is equal to 2W. It's equal to 2 times the width. So the distance around here using one letter and one letter only, we know is 18. So I can say that is W plus 2W plus W plus 2W. Now that is equal to 18 metres. W plus 2W is 3W. Add another 3W would be 6W. So 6W is 18. So W must be 3. The width is 3 metres. That means the length is twice as much. That's 6 metres. Part B says, Bethan decides to build a new sheet pen. The perimeter fence of the sheet pen is 16 metres long. The length of the new sheet pen is 3 metres longer than the width. Form an equation and solve it. So very similar to what we just did. So we know that the full distance around is going to be perimeter is equal to 16. This is the width, this is the length. Now, they're 2 different letters, which can be too hard to solve at the moment, but it's this key fact here. The length is longer than the width by 3 metres. So I can say that L is equal to what the width is plus 3. Okay, so the distance around here is going to be W plus 3 plus W plus W plus 3. That would be coming here, then going across here, up here, back to the 16. So I can say that's equal to 16. I've got 1, 2, 3, 4 W's. So 4W plus 3 is 6 is equal to 16. I'm now going to take 6 off each side. So 4W is equal to 10. And then I'm going to do 10 divided by 4. So I'm going to halve top and bottom to get 5 divided by 2. And 5 divided by 2 is 2.5. So the width is 2.5. And the length is 3 metres longer. So it's 5.5. Okay? Okay then, over the page, it says, Ollie and Joseph both have jobs in a workshop that make decorations. They make decorations using small squares of stained glass. Ollie has made the following decorations: D1, D2, D3, D4. Okay? He labels the first decoration D1, the next three decorations as D2, 3, 4. So we can see all of that stuff there. He continues to make the decorations and the labels for following this pattern. After making decoration 5, Ollie notices he only has 10 small... After making decoration 5, Ollie notices he only has 10 small squares of stained glass left. How many more squares of stained glass will he need to make decoration D6? Okay, so first of all, how many are there in each pattern? So there's 1 there, 3 there, 3 and another 3 makes 6, 6 there and 4 makes 10. So we're adding on 1 more each time. So we've added 2, then add 3, then add 4. So for pattern D5, we would add on 5, so it would be 15. And for pattern D6, you would add on 6, so you'd have 21. Now, we know that in pattern D6 we need 21. He's already got 10 small squares of stained glass left. How many more will he need? So we're saying something plus 10 is equal to 21. In other words, what's 21 take away 10? Oh, I can't write today. 21 take away 10 would tell me what that is. So he needs 11 more squares. Part 2 says Ollie uses a rule to work out the squares needed for each decoration. He states to make decoration D10, he would need 55 squares. Is he correct? Okay, so we know from D5 and D6, we've worked those out already. So let's carry on that pattern and see if he's right. Right. So there's D7, D8, D9, D10. So we've added on 2, 3, 4, 5, 6. Now I want to add 7 onto that. So that would be 28. We then want to add 8 onto that. So that would be 36. We then want to add 9 onto that. So that would be 45. We then want to add 10 onto that to get 55. That's D10. He said it was 55. So make sure you've answered it. Yes, he's correct. Over the page, it says Joseph has made the following 3 decorations using the same small squares of stained glass. Joseph has labelled them P1, P2, P3 in that order. Joseph continues to make the decorations following the pattern he has started. How many more squares would he need to make pattern 22 than to make pattern 18? Now, I'm not doing what we just did for the other guy, okay? It's going to take too long to do that. We've got to try and spot 3. How many squares are in this pattern? 5. How many squares are in this pattern? 7. This is going up in the same amount each time. So what I want to do is find the nth term rule. It's going up in 2s every time. So it's going to be up in 2 n's. And then if I come back in front of the first one here, so if I work out the P0, if I've gone up in 2s this way, this must be going down in 2s, which should be 1, which will be a positive 1. The nth term is 2n plus 1. So to find the 18th pattern, I would do 2 times 18 and then add 1, which would give me 36, add 1 is 37. To find the 22nd pattern, I do 2 times 22 and then plus 1. That would be 22 times 2 would be 44, add 1 would be 45. So how many more are needed? So let me make sure I've made that obvious. 8 more needed. Joseph has 22 squares. He states, I think I can make 1 complete decoration by using all 22 squares with none left. Is he correct? The answer is no, because every time the pattern has always been odd. So the number will always be odd because you're always just adding on 2 to an odd number. So I'm going to say pattern is always odd. And then it says each small square of stained glass measures 0.5 centimeters by 0.5 centimeters. The perimeter of one of Joseph's decorations is 10 centimeters. Complete the label that would do that. Okay, so for this one here, for pattern number 1, we are going to have 1, 2, 3, 4, 5, 6, 7, 8. We are going to have 8 lots of 0.5. So 8 lots of 0.5 would be 4 centimeters. Okay. By then adding on a square here, we're going to add on 1, 2, 3, 4, 5, 6 to that perimeter. No, that would be there anyway. Let's just add up all the total. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for pattern 2, we've got 12 times by 0.5, which would be 6 centimetres. We know that his perimeter is going to be 10. These are going up in 2 centimetres. So then we would have 8 centimetres there. Then we would have 10 centimetres there. So this is going to be pattern number 4. So the fourth pattern there would be P4. Okay? Okay, and over the page, onto page 20, we've got a cumulative frequency diagram. We're told that Cambria Airlines has planes that can carry up to 70 passengers. For safety, the crew practice the emergency exit procedures with a group of 70 passengers. Every 10 seconds, the safety officer records the total number of passengers who have left the plane. He displays the results in a cumulative frequency table. First of all, work out the median time. Okay, so there's 70 people. We need to find the middle of that, which would be 35. We draw a line from the cumulative frequency at that value of 35, and we come down and read it off. It's bang in the middle of 40 and 50, so it must be 45 seconds. Part 2 then says, how many passengers took more than 50 seconds? Okay, so more than 50 seconds is these passengers here. So we come up to the graph, we read off how many people are that. Okay, so we know that we've had 70 passengers there. Earlier than 50, there were 40 passengers. So basically, we want to know what is this size here. How many people are there between 40 and 70? So we need to do, they haven't given me any room to work it out. So we want to do 70, take away 40, which would be 30 passengers represented here. It then says Cambria Airlines has the policy that states the following. In the event of emergency exit procedure, at least 90% of the 70 passengers must have left the plane within 1 minute. Did the practice work? Okay, so 1 minute is 60 seconds. So we need to go and work out how many people had left by 60 seconds. So if I come up here, there, and come across there, we've got 65 out of 70 people. I don't know if that's going to help me at all here. 65 out of 70. To change that into percentage, that's not going to be very nice. So I'd say ordinarily times by 100, but as a percentage, I don't know what that is. So what I'm going to do instead is work this out a slightly different way. 90% of 70, well, I know what 10% is, 7, so 90% must be 63. We need to have at least 63 people have left by then. I found out that 65 people had left by then, so 63 is definitely less than that. So by 1 minute, 65 had left. So yes, this passed. Okay. Question 11. So it's given us some box and whisker diagrams. It says, in which of the 5 months was the median flow of water the greatest? Okay, I haven't read the box and whisker plots show the flow of water through a drain measured in meters cubed per second. The flow of the water is measured at 11 a.m. each day for the first 5 months. So which was it at the median, the greatest? The median is always the middle line. So I'm looking for the highest median, which is that middle one there, April. Do I need to actually go and work out what it was? No, I didn't even need to work out what it was, okay? I have done effectively, but I only need to say April. So April, and that would have been at 37 if I bothered to write it, 37 meters cubed per second. Okay. We're then asked in part B, in which of the 5 months did the range of the water flow have its greatest? Now, in terms of the box and whisker diagram, that's the median, lower quartile, upper quartile. This is the maximum, this is the minimum. So I'm looking for the biggest distance between the maximum and the minimum for the range. It's actually the one that I've recorded. I can see that's a smaller range, smaller. That could be similar, actually. I'll work that one out as well, just for safety. That one's got a very small range, and that one is just smaller. No, this one's exactly the same. So May and March are exactly the same. So I'll go and work out January, and I'll go and work out May. So Jan's one is 40 take away 10. So 40 take away 10 is 30. And then if we look here, we've got, what, 48 take away 20, so it's 28. Yeah, it's January. So that's my month. Okay, so January is my month there. It then says, Iona is writing some statements on a report on the flow of water through the drain. Complete each of the statements given below. Both the upper quartiles and the medians of the month of blah, blah were the same. So the upper quartiles and the medians. So I'm looking for medians to be the same. So it's only those ones there that are the same anyway, and they have the same upper quartile. So that's Jan and Feb. And then it says 25% of the results in March show that the flow of water was greater than. So if we look at March here, this is the upper quartile. They want it up greater than. So if it's an upper quartile, that's 75%. So that tells you that this bit here would be 25%. So 25% is greater than 43. Reading off that, 43. Okay. It then says circle either true or false for each of the following statements. It says 25% of the results in January show that the flow of water was less than 6 meters cubed. So 25% would be the lower quartile, which is like 15, so that's false. It then says the units meters cubed measure the volume of water passing through the drain each second. Well, that's true. They told us that in the question. Meters cubed per second measure the volume of water in meters cubed passing through every second. Yes, that's true. It then says the mean flow of water in April was certainly greater than 36 meters cubed. So April 36, the mean flow is certainly greater than that. Oh, the mean? No, we don't know what the mean is. The median value is 37. I had it as, but 37 is the median. It's not necessarily the same. So when it says certainly, that's the key word here. You'd assume it probably is, but we're not certain. Okay. And then it says here, the month with the greatest difference between the lower and the upper quartile was May. So between the lower and the upper quartile, no, that's the biggest one. It's really, really long, that one is. That was much shorter. It's interquartile range. So that's false as well. Okay, then, over the page. Nearly there. Yeah, we've got 2 more questions to go. 1 big question, 2 more questions. Number 12 says, a standard piece of A4 paper is usually 0.0 millimeters thick. Write this in terms of standard form. So we've got millimeters, centimeters, then meters. To change something from meters into centimeters, I would times it by 100. And then to change between centimeters to millimeters, I would times by 10. Conversely, working the other way, I'd divide by 100 and divide by 10. Okay? So if I'm going to go from millimeters of thickness into meters of thickness, I'm going to divide by 10, divide by 100. Sorry, that should say divide there. Now, in terms of that, I want to do 0.08 divided by 10, which would be 0.008, and then divided by 100, so it would be 0.00008. Okay? Now, that would then move the decimal 1, 2, 3, 4, 5 places to the left, so it would be 8 times 10 to the power of minus 5. It then says a piece of card is 1 millimeters thick. A stack of these is 3 times 10 to the minus 2. Calculate how many pieces of card there are in the stack. Well, again, they've done it in meters and millimeters. So I'm going to say here that 1 millimeter is equal to 0.1 centimeters by using this, divided by 10, be equal to 0.01 millimeters. No, hang on. No, that's right. Divided by 100 is that. So if I've got this here as 0.03, so that would be meters, not millimeters, meters high, I want to know 0.03 meters, which is the stack, divided by 1 piece, so divided by 0.001 meters, so that's for 1 piece. Too hard to work out as it is. I don't want that being 0.001. I'm going to times that by 1,000 to get 1. But whatever I do to the top, I do to the whatever I do to the bottom, I do to the top. That's going to be 30 divided by 1. There are 30 pieces in the stack. It then says, what assumption have you made in answering this question here? I've made the assumption that all card is the same thickness. Okay. And then over onto part C, it says, In 2012, it was recorded that the total mass of paper used for printing newspapers in the world was 2.88 times 10 to the power 7 tons. The world population is approximately 7.2 times 10 to the 9. Use this information to calculate the mass of the paper per person used to print newspapers in 2012. Give your answer as in terms of kilograms per person. Now, notice they bolded that and they bolded that. That is because they're in different measures, okay? This one's actually fine. This one's in terms of people. So, first of all, I need to know the following conversion. 1 ton is equal to 1,000 kilograms, okay? Okay, so the next thing I know is that to change tons into kilograms, I times it by 1,000. To change kilograms into tons, I divide by 1,000. Now, talking standard form, I'm going to times by 10.3. I'm going to divide by 10 to the power of 3, sorry. Okay, so what I'm going to do is change 2.88 times 10 to the power of 7 tons. I'm going to times it by 10 cubed to change that into kilograms, and that would effectively be 2.88 times 10 to the power of 10 in terms of kilograms. It then says, work out the total mass of paper per person in kilograms per person. So I now want to do my answer, which is 2.88 times 10 to the power of 10 kilograms per, means divide, person. So person is 7.2 times 10 to the power of 9. Now, I can do some of this nicely. Some of it's really hard, actually, trying to do it like this. The first thing I can do is just deal with the powers of 10. So I've got 2.88 over 7.2. And then I'm going to just deal purely with these because these are easily worked out. But I don't know how many 7.2 is going to 2.88. So it's going to be that times 10 to the power of 1. Now 10 to the power of 1 is 10. And because that's timesing it, I can just times by the numerator. So I can say that's 28.8 divided by 7.2. So then I just want to count the 7.2s until I get to 28.8. So if I double it, I get 14.4, 21.6, 28.8. So that is 1, 2, 3, 4. So the answer is 4 kilograms per person. Okay, that was the last question. Hopefully that video has been useful. If it has been, please hit the subscribe button. You'll have access to any more papers as and when I release them. Thanks very much for watching.